This is Chemistry, Unit 6, Chemical Composition. We can also use molar mass to determine atoms, molecules, and particles. Grams to atoms. Let's look at my first example. It says, how many atoms are in 20.1 grams of calcium? So you have an amount of calcium, right? You have a mass of calcium. Can you figure out how many individual atoms are in that mass of calcium? And the answer is yes, using both conversion factors that we studied in this unit. So you will start with what was provided in the problem. You were given 20.1 grams of calcium. So that's your starting point. Now, if you're starting with mass, your next step must involve the conversion factor using molar mass, right? Because it's a mass. So you look up calcium's molar mass, it's 40.078. We'll round that to 40.08. And that's comparable to 1 mole. So why did I put the grams on the bottom? Because I'm trying to cancel the grams that I'm starting with. So this 40.08 grams is in the bottom of my t-square, and it's comparable to 1 mole. And this came from the periodic table. So now your grams cancel, and you're left with mole. But the question was not how many moles are in this mass. The question was how many atoms. So you'll use the second conversion factor that we've been studying. It's the mole to the atom. So in 1 mole, you have 6.02 times 10 to the 23rd atoms. Why is the 1 mole on the bottom? Because you want to cancel the mole of calcium from the previous step. So now you're left with atoms. Now to solve this is where I recommend parentheses, but that's totally up to you. Just make sure you're typing in the 6.02 properly with the EE key. So in the calculator, you have 20.1. You can times it by 1, and then times it by 6.02, the EE key to the 23rd. And then on the bottom, you have this 40.08. If you need to times it by 1, you can. That's not really necessary, and that's a place where I might use the parentheses, right? But you don't really have to multiply it by 1 since it is just 1. If this were a different number, then that would be a different calculation. But in any case, you will divide by 40.08. And you should have, as an answer, 3.02 times 10 to the 23rd atoms. Now, your calculator might say 3.02, and if you look all the way at the end, it'll say e to the 23. E is the same thing as times 10, right? That's why we're using that EE key. It's referring to exponent. And now I rounded this to 3.02 to match the significant figures that I started with. Okay, so just be careful how you're plugging this into your calculator. All right, what about atom to gram? So now question 2 is asking how many grams are in 4.1 times 10 to the 20 atoms of platinum. So you have a lot of atoms of platinum. How many grams is that? Well, this time you will start with atoms. 4.1 times 10 to the 23rd atoms. And of the 2 conversion factors that you've learned, you need to use the one that has atoms as your next step. So the only number we can associate with atoms is that 6.02 times 10 to the 23rd. That will be placed on the bottom, and that's comparable to 1 mole. That's placed on the top. Atoms is on the bottom because you want that to cancel with the atoms that you started with. But you were not asked for mole. You were asked for gram. So you need to use that second conversion factor that involves grams. So this means now you have to look up platinum on the periodic table, which is right here. It's 195.08. So that's our conversion factor. That's the molar mass. So 1 mole will be placed on the bottom, and 195.08 grams will be placed on the top. Why? Because you want the moles to cancel, and you want to be left with grams. Now to solve this, you take 4.1 EE key to the 20th times 1 times 195.08. And then you will divide by 6.02, the EE key to the 23rd, and you don't really need, in either step, you don't really need to multiply by 1. It's just easier to keep this here because you can see it, but on the bottom, if this is just 1, you really don't have to multiply it by 1, but you are free to do so. If you intend to do so, I do suggest parentheses. But in any case, when you hit enter, the correct answer with correct significant figures to match my 4.1, that's only 2 significant figures, is 0.13 grams of platinum.